we are discussing about the very important topic from the organic chemistry, fundamentals of organic reaction mechanism. ठीक आहे, या टॉपिक मध्ये सेकंड पार्ट जो आहे यातला त्याची सुरुवात आपण लास्ट लेक्चर पासून केलं होतं, अँड दॅट इज रिॲक्शन इंटरमिडिएट. वी हॅव स्टडीड फर्स्ट टू इंटरमिडिएट्स इन डिटेल. मग त्यामध्ये कार्बोकॅटायन आणि कार्बॅनियन या दोन इंटरमिडिएटचं आपण डिटेल डिस्कशन केलं होतं. अँड वी हॅव स्टडीड दॅट इंटरमिडिएट इन 5 स्टेप. 5 स्टेप मध्ये याचं आपण डिस्कशन करतोय. फर्स्ट इंट्रोडक्शन, just definition and some properties. Then second is the formation. Third one is the structure. Fourth one is the stability. And last one is the reactivity. Now we have studied both the reaction intermediate in detail about that carbocation and carbanion. Now let us see next one. यामधला पुढचा reaction intermediate आपण आज बघतोय. One of the important intermediate, free radicals. Now let us see what is meant by free radical. First, I will explain how that free radicals are generated, how they are formed. Let us say simple organic process. This is the aged organic compound. There is a covalent bond between A and Z. Suppose this covalent bond undergo homolytic bond breaking. Then what happens? Here one electron goes towards A, another electron from the bond, it goes towards Z. Means A acquired one electron, Z also acquired one electron, and that species are called free radical. Okay, here that covalent bond undergo homolytic bond breaking, and each species acquire unpaired electron. That species are called free radical. Now let us say actually some properties of free radical. याच्या काही properties आपण बघूया free radical कशाला म्हणायचं. First one, पहिला point आपल्याला काय सांगता येईल, that properties are highly, that species are highly reactive. That free radicals are highly reactive. Means they can easily combine with another species. Means simply we can say that they are highly reactive species. This is the first property. Second one, they having unpaired electron. There is unpaired electron on the A. There is unpaired electron on the Z, and that species are called free radical. This is the second point. They are having unpaired electron. आणि यामध्ये तिसरी एक प्रॉपर्टी कोणती महत्वाची आहे? They are formed by homolytic bond breaking. They are formed by homolytic bond fusion, and such species are called free radical. Now, how will you define that concept? How will you define free radical? Simply we can say they having three main properties. They are highly reactive, they are having unpaired electron, and they are formed by homolytic bond breaking. Okay, thus highly reactive species, the highly reactive species having unpaired electron and which is formed by homolytic bond breaking is called free radical. The highly reactive species which having unpaired electron and formed by homolytic bond breaking is called free radical. त्याला आपण free radical असं म्हणतो. Let us say example. Here CS3, carbon having unpaired electron, Cl having unpaired electron. These are the examples of free radical. Okay, this CS3, this is called actually methyl free radical. Okay, we can show that methyl free radical like that. Carbon attached to the 3 hydrogen atom, and here carbon having unpaired electron. Actually, this is the methyl free radical. Okay, and thus here carbon having unpaired electron. That species are also called as the alkyl free radical, chlorine free radical. These are the examples of free radical. Okay, let us see some properties of that free radical. यामध्ये पहिली प्रॉपर्टी आपल्याला काय सांगता येईल बघा. These are electron deficient species. Now, why they are electron deficient? How many electrons are there in the valence shell of that alkyl free radical? Yes, let us see that carbon is having 3 covalent bond. It having 3 covalent bond means there are 2 plus 2 plus 2 means there are 6 bonded electron, and there is 1 unpaired electron. Means totally there are 7 electron in the valence shell of carbon. There are 7 electron in the valence shell of carbon. Means simply we can say that it having 1 electron less to complete its octet. It having 1 electron less to complete its octet. Means there is a deficiency of electron. 8 electron असायला हवे, then only it is complete octet. But there are only 7 electron. Means simply we can say that it is electron deficient species. Okay, this is our first property. Yes, it is electron deficient species. Then due to deficiency of electron, it acts as an electrophile. We know that electrophile means neutral molecule which having electron deficient center. Free radical also do not having any charge. but there is a deficiency of electron and therefore it is an electrophile, म्हणून त्याला आपण इलेक्ट्रोफाइल असं म्हणतो. These are the properties. This is the first actually step, introduction of free radical. यामध्ये आपण काय पाहिलं, just definition of free radical. Yes, highly reactive species having unpaired electron and which is formed by homolytic bond breaking is called free radical. These are the examples of free radical, and there are two properties made. One, it is electron deficient species, and second, it is an electrophile. Okay, this is first step, introduction. Now let us see second step is the formation, how they are formed, how they are generated in chemical reaction. Let us see simple example of generation. This is a covalent bond between a two chlorine atom. This is Cl2 molecule, chlorine molecule, and there is a covalent bond between a two chlorine. We know that there is a covalent bond, means there is one electron pair. This is called bonded electron pair. Suppose that chlorine molecule undergo homolytic bond breaking in presence of ultraviolet light. Now what happens here? There is a homolytic bond breaking, means there is a equal distribution of electron. Here what happens? One electron from the shared pair goes towards one chlorine atom. It acquires one electron. Then second chlorine also acquires one electron from the shared pair. Thus, first chlorine having one electron, second chlorine also having one electron, and that species which having one electron, that species which are highly reactive, they having unpaired electron, and that species are called as the free radical. And thus simply we can say that free radicals are generated by homolytic bond breaking, and that bond breaking always takes place in presence of ultraviolet light, in presence of nonpolar solvent, in presence of nonpolar solvent, and in presence of ultraviolet light, or in presence of hydrogen peroxide. That homolytic bond breaking easily occurs and we get the free radicals. Okay, this is the generation, how the free radicals are formed. Let us see third point. Third step is the structure. Here we have to study structure of alkyl free radical. Alkyl free radical means carbon having unpaired electron. Let us see what is the hybridization of carbon, then what is the geometry and bond angle in that free radical, alkyl free radical. Okay, this is our alkyl free radical. We know that carbon is attached to the 3 covalent bond and it having unpaired electron. Now what should be the hybridization of that carbon? Hybridization of that carbon is a sp2, similar to carbocation. In carbocation, the hybridization of carbon is sp2. Here also hybridization is sp2. But in case of carbanium, hybridization was sp3. Here hybridization is sp2, means there are 3 hybrid orbital. Then how the covalent sigma bonds are formed? Suppose this is the central carbon atom of alkyl free radical. Now it is having 3 covalent bonds. How that covalent bonds are formed? That bonds are formed due to overlapping of 3 hybrid orbital of carbon with orbitals of another atom, and thus there is formation of 3 sigma bond. In alkyl free radical, hybridization of that central carbon is sp2. There are 3 hybrid orbital. They form 3 covalent bond. These are the 3 covalent bond. Then there is one unhybridized orbital. This is unhybridized 2pz orbital, and carbon having unpaired electron. That electron is present in that unhybridized orbital. Okay, this is the unpaired electron. I have shown by red color. Okay, this is the unpaired electron, and it is present in the 2pz orbital. That 2pz orbital lies perpendicular to that main plane. Okay, this unpaired electron, second point I have shown that unpaired electron is present in unhybridized p2pz orbital. Now what should be the geometry here? What should be the, hybridization is sp2, means geometry should be trigonal planar. Geometry of that species should be trigonal planar, and bond angle should be 120 degree. This is the third point. Geometry is trigonal planar with bond angle 120 degree. And example is the methyl free radical, which is planar in nature, having bond angle 120 degree. This is about the structure स्ट्रक्चर मध्ये सिंपली आपण एक 3 किंवा 4 पॉइंट एक्सप्लेन करतोय. फर्स्ट, हायब्रिडायझेशन ऑफ कार्बन. हे लक्षात ठेवा, हायब्रिडायझेशन ऑफ कार्बन इज sp2 always. Then second, unpaired electron is present in unhybridized 2pz orbital. Second point. Third one is the geometry is a trigonal planar with bond angle 120 degree. An example is the methyl free radical, which is planar in nature, which is trigonal planar in nature. Okay, this is about the third step structure. We have studied 3 steps regarding the free radical. One, introduction. Second, generation. And third one is the structure. Let us see. Next step is the stability of that free radical. Stability of that free radical. Now, similar to carbocation, here also there is a role of inductive effect. Here there is also role of another effect like hyperconjugation and resonance effect. But we are going to discuss only one concept, how there is a role of inductive effect in the stability of free radical. फ्री रॅडिकल वरती या इंडक्टिव्ह इफेक्टचा काय इन्फ्लुएन्स होतो, हाऊ इट इन्फ्लुएन्स द स्टॅबिलिटी, हे आपण यामध्ये स्टडी करतोय. जस्ट कंपॅरेटिव्ह स्टॅबिलिटी अमंग द सम एक्झाम्पल. लेट अस सी सम एक्झाम्पल्स ऑफ फ्री रॅडिकल. ओके, दिस इज मिथिल फ्री रॅडिकल. Carbon is attached to the 3 hydrogen atom. There is unpaired electron. Suppose one hydrogen replaced by methyl group, then it becomes methyl free, primary free radical. 2 hydrogens are replaced by 2 methyl group, secondary free radical. And all the 3 hydrogens are replaced by 3 methyl group, then it is tertiary free radical. Okay, these are some of the example. Now let us see comparison between first two. पहिल्यांदा मी comparison करतो पहिल्या दोन मध्ये. Suppose this is the first one and this is the second one. This is second one. Okay, which is more stable among that two. Now I have one statement regarding the free radical, alkyl free radical. In alkyl free radical, central carbon having only 7 electron. Therefore, it is electron deficient. Central carbon is electron deficient because it having only 7 electron. It having 1 electron less to complete its octet. Now, therefore, what is the criteria? Yes, here in the case of that primary free radical, in the case of that second example, that methyl group shows electron donating inductive effect. That is called plus I effect. याला आपण इलेक्ट्रॉन डोनेटिंग प्लस I effect असं म्हणतो. Why there is electron donating inductive effect? Means that bonded electron pair is pulled towards central carbon, and this is called plus I effect. Means alkyl group, methyl group shows plus I effect. It having electron donating inductive effect. Okay. Therefore, what happens? Okay, central carbon is electron deficient. त्याकडे इलेक्ट्रॉनची कमतरता आहे. And hence, when electron donating group is attached to that central carbon, then stability of that free radical increases. Hence, that second example, that primary free radical is more stable than first one. It is more stable than methyl free radical. This is due to the plus I effect of methyl group. And that stability order is similar to carbocation. In carbocation also there is the same order, because in carbocation also central carbon is electron deficient, and here also there is the same order. Now let us see next example. Here in the case of secondary free radical, there are again 2 methyl group, means there is again more plus I effect, hence it is more stable than primary. While in the case of tertiary, there are 3 methyl group, they having plus I effect, and therefore again it is more stable than secondary as well as primary. This is just about the stability order of free radical, and it is totally depends upon electron donating inductive effect of methyl group. Central carbon of alkyl free radical is electron deficient, hence plus I effect. Hence, electron donating group increases the stability of free radical. Okay, this is just about the stability. And let us see last point, last step, reactivity. Reactivity means we have to study just one simple example of that particular organic reaction which involve formation of free radical as an intermediate. आपण यामध्ये एक सिंपल एक्झाम्पल स्टडी करणार आहोत की ज्यामध्ये या फ्री रॅडिकलचं फॉर्मेशन होतं ऍज अन इंटरमिडिएट, अँड नेम ऑफ दॅट पर्टिक्युलर रिएक्शन इज अ फोटोक्लोरिनेशन ऑफ मिथेन. Photo means when a reaction is carried out in presence of light, that reactions are called photolytic reaction. This is also photolytic reaction. Simple example, suppose chlorine is exposed to the ultraviolet light. What happens? That chlorine molecule undergo dissociation. There is homolytic bond breaking. One electron goes towards one chlorine, second electron goes towards second chlorine, and there is the formation of chlorine free radical. This is homolytic bond breaking, and we get the chlorine free radical. Suppose that chlorine free radical comes in contact with methane. When they comes in contact with methane, CH4. Now what happens here? Suppose that one chlorine atom comes in contact with methane. What happens here? One of the bond between carbon and hydrogen, the bond between CH, is also undergo homolytic bond breaking. One electron goes towards carbon, second electron goes towards hydrogen. Now what happens here? That hydrogen having unpaired electron, chlorine having unpaired electron, and there is a formation of bond between hydrogen and Cl, and we get the HCl. HCl. What is the main product? Here carbon having unpaired electron, carbon having unpaired electron. Thus there is a formation of methyl free radical. This is the methyl free radical. In first step, chlorine molecule undergo dissociation, it undergo homolytic bond breaking, we get the chlorine free radical. In second step, that chlorine free radical further react with the methane. The bond between carbon and hydrogen undergo homolytic fission. Okay, and there is formation of HCl and carbon having unpaired electron, and this is the methyl free radical. Now in the next step what happens? That methyl free radical, या second step मध्ये तयार झालेला methyl free radical further react with the another molecule of chlorine. तो क्लोरीनच्या नवीन molecule बरोबर react होतो, and here in presence of that in presence of that methyl free radical, that chlorine molecule again undergo homolytic bond breaking. या मिथिल फ्री रॅडिकलच्या सानिध्यामध्ये काय होतंय? या क्लोरीन मॉलिक्युलचं पुन्हा होमोलिटिक बॉन्ड ब्रेकिंग होतं. म्हणजे वन इलेक्ट्रॉन गोज टुवर्ड्स वन क्लोरीन, सेकंड इलेक्ट्रॉन गोज टुवर्ड्स सेकंड क्लोरीन. नाउ दिस वन क्लोरीन having unpaired electron, carbon having unpaired electron, that carbon and one chlorine share their electron to form a bond between carbon and chlorine. आणि सेकंड क्लोरीन जो आहे इट हॅव्हिंग अनपेड इलेक्ट्रॉन, तो इथं मी दाखवलाय. while this is the new bond between carbon and one chlorine. This is the new bond between carbon and one chlorine. Okay, म्हणजे इथला जो क्लोरीन आहे which having unpaired electron आणि carbon which having unpaired electron, they share their electron with one another to form a covalent bond, and this is just a formation of methyl chloride, and that reaction is called photochlorination of methane. Methane, when it reacted with the chlorine in presence of ultraviolet light, we get methyl chloride, and that reaction involves formation of free radicals as an intermediate, आणि या रिएक्शन मध्ये फ्री रॅडिकल्स तयार होतात as an intermediate, and therefore that reaction is called as the photochlorination because it is carried out in presence of light, in presence of actually this is photolytic reaction, hence it is photochlorination of methane. Okay, this is just about the reactivity. Actually we have studied example of simple organic reaction, and that reaction involve formation of free radical as an intermediate. आपण या ठिकाणी फ्री रॅडिकल या इंटरमिडिएटचा स्टडी करतोय. ऍक्च्युअली फ्री रॅडिकलचा स्टडी आपण 5 स्टेप्स मध्ये केलेला आहे. फर्स्ट स्टेप इज द इंट्रोडक्शन. यामध्ये आपण काय स्टडी केलं? व्हॉट इज द डेफिनेशन? येस, इट इज highly reactive species having unpaired electron and formed by homolytic bond breaking is called free radical. यामध्ये प्रॉपर्टी मध्ये 2 पॉइंट्स आपण पाहिलं. फर्स्ट, इट इज इलेक्ट्रॉन डेफिशियंट स्पेसीज, आणि सेकंड, इट इज अन इलेक्ट्रोफाइल. ओके, त्यानंतर सेकंड पॉइंट आपण पाहिला, हाऊ दे आर जनरेटेड. जनरली फ्री रॅडिकल्स आर फॉर्म ड्यू टू होमोलिटिक बॉन्ड ब्रेकिंग. त्यानंतर थर्ड पॉइंट आपण पाहिला, स्ट्रक्चर. स्ट्रक्चर मध्ये महत्वाचं काय आहे? व्हॉट इज द हायब्रिडायझेशन ऑफ कार्बन? यस, sp2 हायब्रिडायझेशन त्यामध्ये. सेकंड पॉइंट, अनपेअर्ड इलेक्ट्रॉन इज प्रेझेंट इन द 2p z ऑर्बिटल. आणि थर्ड पॉइंट मध्ये पाहिलं आपण, जॉमेट्री इज अ ट्रायगोनल प्लेनर विथ बॉन्ड अँगल 120. इट इज सिमिलर टू द कार्बोकॅटायन. आणि फोर्थ पॉइंट आपण पाहिला, स्टॅबिलिटी ऑफ free radical. It is similar to the carbocation because it is again electron deficient species. Therefore, electron donating group increases the stability of free radical. Hence, tertiary free radical is more stable than secondary, and which is again more stable than primary, and which is again more stable than methyl free radical. And last point we have studied, yes, reactivity, example of simple organic reaction. We have studied how the photochlorination of methane is occurred in presence of ultraviolet light, and how there is a formation of free radical as an intermediate. Okay, now let us see नेक्स्ट रिएक्टिव्ह इंटरमिडिएट. ऍक्च्युअली आपण आतापर्यंत 3 इंटरमिडिएटचं डिस्कशन केलं. फर्स्ट वन इज द कार्बोकॅटायन, सेकंड वन इज द कार्बॅनियन, अँड थर्ड वन इज द फ्री रॅडिकल. अँड वी हॅव स्टडीड दॅट इंटरमिडिएट्स इन डिटेल. पण या नंतरचे जे इंटरमिडिएट्स आहेत ते मात्र आपण इन शॉर्ट आपल्याला त्याचा स्टडी करायचा आहे. थोडक्यामध्ये आपण बघणार आहोत. जस्ट डेफिनेशन अँड एक्झाम्पल हे फक्त आपण बघतोय. नाउ लेट अस सी नेक्स्ट रिएक्टिव्ह इंटरमिडिएट. हा तुमच्यासाठी नवीन असणारा इंटरमिडिएट आहे कार्बीन. नाउ लेट अस सी example of carbene. This is called carbene. Here, what is the main concept of that carbene? Carbon is attached to the 2R group, means it having 2 covalent bond. Then there is one electron pair also. त्यावरती एक electron pair दाखवलेले आहे. This is non-bonded electron pair actually. Now, what is the property of that carbene? काय property सांगता येईल आपल्याला? Yes, it having 2 covalent bond, means it is divalent species. Carbon is a divalent species. Carbene is a divalent species. Second point काय सांगता येईल? It is neutral in nature. It do not having any charge. There is no positive or negative charge. Means it is neutral. Now, how many electrons are there in the valence shell? Electrons किती आहेत? This bond having 2 electron. Second bond also having 2 electron. While there are 2 non-bonded electron. Thus, totally 4 bonded and 2 non-bonded. Means totally there are 6 electron in its valence shell. त्याच्या valence shell मध्ये only 6 electrons आहेत. This is the third point. म्हणजे आपल्याकडे 3 points आहेत. First, it is divalent in nature. It having only 2 covalent bond. Second point, it is a neutral carbon species. It is a neutral in nature, do not having any charge. And third one, it having 6 electrons in its valence shell. Now, how will you define? By using that 3 property, the divalent neutral carbon species, the divalent neutral carbon species which having 6 electrons in its valence shell is called carbene. याला आपण carbene असं म्हणतो. Okay, now let us see some property. Yes, it is electron deficient. Now, why carbene is electron deficient? Yes, again it having 6 electron in its valence shell. Means there are 2 electron less to complete its octet. Therefore, there is a deficiency of electron. म्हणून आपण त्याला इलेक्ट्रॉन डेफिशियंट स्पेसिस असं म्हणतो. मग इलेक्ट्रॉन डेफिशियंट असेल तर त्याला आपण काय म्हणूया? Yes, it is electrophile. Yes, it acts as a electrophile. Okay, these are the examples of carbene. CH2, carbon having 2 electron. Then again CCl2, carbon having 1 non-bonded electron pair. Okay, this is just about the carbene. In short, we have studied what is meant by carbene. The divalent neutral carbon species having 6 electron in its valence shell is called carbene. It is electron deficient and it acts as an electrophile. Okay, this is just about the carbene. Now let us see next. यामध्ये पुढचा आपण पॉइंट बघूया. What is about nitrene? Again, next reactive intermediate. Nitrene बद्दल आपण बघतोय. This is also one of the important intermediate formed in the organic reaction, and this is example of nitrene. CH3, CH2, a single bond. Nitrogen. Generally, nitrogen having 1 lone pair of electron. मग तो अमोनिया असेल, प्रायमरी अमाइन असेल, सेकंडरी अमाइन असेल. नायट्रोजन वरती 1 लोन पेअर ऑफ इलेक्ट्रॉन असते. बट इन नायट्रीन, नायट्रोजन हॅव्हिंग ओनली 1 कोव्हलंट बॉन्ड. जनरली नायट्रोजन किती बॉन्ड दाखवतो आपण? देर आर 3 कोव्हलंट बॉन्ड. ट्रायव्हॅलंट असतो. बट हियर इट हॅव्हिंग ओनली 1 कोव्हलंट बॉन्ड. आणि यामध्ये 2 लोन पेअर ऑफ इलेक्ट्रॉन दाखवलेले आहे. मग त्याची प्रॉपर्टी मध्ये काय सांगता येईल? येस, इट इज मोनोव्हॅलंट. It having only 1 covalent bond, means it is monovalent. Then it is nitrogen species. Actually, this is monovalent nitrogen, not carbon species. It is, we are concentrating on the nitrogen. Therefore, it is monovalent nitrogen species. Now, how many electrons are there in the valence shell? Valence shell मध्ये इलेक्ट्रॉन किती आहेत? Okay, this bond having 2 electron. मग पुन्हा इथल्या 2 इलेक्ट्रॉन. Again, 2 lone pair of, sorry, 1 lone pair of electron, means totally 4 bonded and 2 4 non-bonded and 2 bonded. Means again there are 6 valence electron. Means third point is the yes, it having 6 electron in its valence shell. मग आपल्याकडे 3 पॉइंट्स आहेत. It is monovalent species having 1 covalent bond. Second, it is nitrogen species actually. And third, having 6 electron in its valence shell. Now, how will you define the monovalent nitrogen species which having 6 electrons in its valence shell is called nitrene. त्याला आपण nitrene म्हणतो. This is well-known example of that nitrene. Now, what's about the properties? काय property सांगता येईल? Yes, it is electron deficient because again there are 6 electron. Means there are 2 electron less to complete its octet. त्याचा octet complete व्हायला 2 इलेक्ट्रॉनची कमतरता आहे. म्हणजेच तो इलेक्ट्रॉन डेफिशियंट आहे. दिस इज द फर्स्ट प्रॉपर्टी. ओके, दिस इज इलेक्ट्रॉन डेफिशियंट स्पेसिस. ओके, त्यानंतर पुढचा पॉइंट काय सांगता येईल? येस, इट इज अन इलेक्ट्रोफाईल. ते इलेक्ट्रोफाईल म्हणून सुद्धा तो ऍक्ट होतोय. ओके, दिस इज अबाउट जस्ट नायट्रीन. नायट्रीन बद्दल एवढ्याच पॉइंट सफिशियंट आहेत. डेफिनेशन इट्स इलेक्ट्रॉन डेफिशियंट स्पेसिस. ओके, नो व्हॉट आय अराइन्स. अराइन्स आपण कोणाला म्हणतोय? दिस इज एक्झाम्पल ऑफ अराइन. ओके, ऍक्च्युअली इट इज बेंझिन लाईक स्ट्रक्चर. बेंझिन लाईक स्ट्रक्चर. फक्त बदल काय आहे? बेंझिन मध्ये इन बेंझिन देर आर 3 डबल बॉन्ड, बट दिस कंपाउंड हॅव्हिंग 1 कार्बन ट्रिपल बॉन्ड. दिस इज बेंझिन लाईक स्ट्रक्चर. इट इज aromatic in nature, but aromatic carbon having 1 कार्बन ट्रिपल बॉन्ड. बेंझिन मध्ये असा नसतो, पण यामध्ये मात्र एक कार्बन ट्रिपल बॉन्ड आहे. अँड दॅट कंपाउंड इज कॉल्ड अराइन. मीन्स सपोज इट इज न्यूट्रल स्पेसिस, then aromatic ring contain कार्बन ट्रिपल bond and that's called as the aryne. मग सिंपली डेफिनेशन लक्षात ठेवा. the neutral species in which aromatic ring having 1 कार्बन ट्रिपल bond, that species is called aryne. त्याला आपण aryne असं म्हणतो. Again, one of the important intermediate form in organic reaction. And this is just about the first topic from the organic chemistry.